Howdy. Welcome to the first video in Module 17. In this module we'll be looking at two new logical symbols, the conditional symbol and the biconditional symbol. These are the last two symbols that we will be introducing in propositional logic. The conditional symbol corresponds to the English expression if-then, while the biconditional symbol corresponds to the English expression if and only if. As with the three Boolean connectives, the conditional and biconditional symbols are truth functional. That means that their meaning is given by their truth tables. In this video, I'll focus on the truth table for the conditional symbol. We'll cover the truth table for the biconditional in the next video, video 17.2. Both tables are a little counterintuitive, particularly the truth table for the conditional. The conditional symbol in particular differs in some important respects from the English expression if-then. This is one of the reasons that logicians often call about the material conditional, to reinforce the message that conditionals in logic do not behave in exactly the same way as conditionals in English. In a sense, the conditional and biconditional symbols are redundant. What that means is that any sentence containing a conditional symbol or a biconditional symbol is tautologically equivalent to a sentence that does not contain conditional or biconditional symbols. We can see this by studying the truth tables. But even though they are strictly speaking redundant, provided that we have the other Boolean connectives, they're still very important. This is because including them in our logical system makes proofs much easier. Think how often we use and reason with if-then sentences in everyday reasoning. So we will start with the material conditional. Here are the learning objectives for this video. After watching it, you should be able first to give the truth table for the material conditional. Second, to understand how and why the material conditional differs from the English expression if-then. And third, to translate sentences containing the material conditional into logically equivalent sentences that contain only the Boolean connectives. Okay, let's get going. The material conditional is represented in our textbook with an arrow. Older texts sometimes use a horseshoe symbol, so you should be able to recognize that if you come across it. But the arrow has become fairly standard. The expression A arrow B is typically read out as if A then B, but it's sometimes more useful to say A arrow B. I'll use the A arrow B version when I want to talk about the relation between the English sentence if A then B and the logical sentence A arrow B. Here's a little more terminology. In the material conditional A arrow B, the first sentence A is referred to as the antecedent, while the second sentence B is typically referred to as the consequent. As I've mentioned, the material conditional is a truth functional connective, and so its meaning is given by its truth table. The truth table tells us how the truth value of a compound sentence A arrow B is fixed by the truth values of the constituent sentences A and B. The material conditional is obviously a binary connective, and so the truth table will have 4 lines. Here it is, with truth values for the antecedent and the consequent, but with the final column left blank. The best way to think about how to complete the final column is to start by thinking about when the sentence A arrow B is clearly false. Look at the 4 rows and identify which assignments of truth values to the antecedent and the consequent make the conditional sentence A arrow B clearly false. Feel free to stop the video and think about it. Most people typically think that the truth value assignment on which A arrow B is clearly false is the assignment that has the antecedent A coming out as true and the consequent B coming out as false. This is certainly correct. To say that A arrow B is true is to say that if A is true, then B is true. So obviously, if A is true and B is false, then A arrow B cannot be true. So the conditional comes out false on the second line of the truth table. The key to understanding the truth table for the material conditional is to recognize that this scenario with A true and B false is the only scenario on which A arrow B is false. In other words, as long as it is not the case that A is true and B is false, then the material conditional A arrow B comes out as true. So the completed truth table looks like this. Each line is true except for the second. You might well be a little puzzled by this. Most people are. This is because the English expression if then works differently from the material conditional in logic. Certainly, when you have a conditional in English of the form if A then B and A is true and B is false, then the English conditional will certainly be false. But people often think that the English conditional can be false even when this doesn't hold, because in English, conditionals often imply that there is some sort of connection between the antecedent and the consequent. Now, we needn't come to a view about how if-then works in English. What I want to emphasize is that truth-functional logical connectives cannot behave like that. Remember what it means to say that a connective is truth-functional. If a connective is truth-functional, then the truth value of a sentence containing that connective is fixed solely by the truth values of the sentences that the connective connects. What those sentences actually say is neither here nor there. The only information that we're allowed to take into account is information that can appear in a truth table. So, applying this to the material conditional, when we're thinking about the truth value of the sentence A arrow B, then all we can take into account is the respective truth values of A and B. We shouldn't think about what they mean. Here's a way of thinking about it. What the material conditional A arrow B asserts is that there's a very special kind of connection between A and B. What it says is that the truth values of A are connected to each other in the following way. Whenever A is true, then B is true. The only way in which this connection can fail to hold is if A is true and B is false. But what about when A is false? Why doesn't that make the material conditional A arrow B false? Well, in order to make the conditional false, you need a counterexample to the general principle that whenever A is true, then B is true. But the only possible counterexample is if A is true and B is false. So one consequence of this is that any conditional with a false antecedent is going to come out true. It doesn't matter whether the consequent is true or false. This may initially seem odd, but it starts to make sense when you think about it like this. So the material conditional A arrow B says that whenever A is true, then B is true. So the only possible counterexample to A arrow B is a situation in which A is true and B is false. So that means that no situation in which A is false can be a counterexample to the material conditional A arrow B. But then, if no situation in which A is false can be a counterexample to A arrow B, then the conditional must always be true when A is false. So that brings me to the last thing I want to talk about. As I mentioned before, the material conditional symbol is really not necessary, because any sentence with a material conditional is logically equivalent to one that contains only Boolean connectives. So let's take a look at how we can translate the sentence A arrow B into a sentence that does not contain the conditional symbol. We can find a sentence logically equivalent to A arrow B if we can write down a sentence that is true in exactly the same circumstances, i.e. true under exactly the same assignments of truth values to atomic sentences. So let's look at the truth table to see how to do this. Looking at the bottom two rows and bearing in mind the previous discussion, you'll see that A arrow B is true whenever A is false. Now notice that A arrow B is true when B is true, and that there are no circumstances where B is true and A arrow B is false. So that suggests that A arrow B is true when either A is false or B is true. Well, if A arrow B is true when either A is false or B is true, then we just need to find another sentence that is true in exactly those circumstances. That's easy enough. The sentence not A or B will work just fine. So that gives us one sentence that is logically equivalent to A arrow B, namely not A or B. In fact, the two sentences are not just logically equivalent, they're tautologically equivalent. If you're puzzled by this, then wait until you get to exercise 7.1, which will ask you to use bool to construct a joint truth table for not A or B and A arrow B. So we found a sentence that is true in exactly the same circumstances as A arrow B by starting with the rows in the truth table where A arrow B comes out as true. Now let's start with the row where A arrow B comes out as false. As we've repeatedly said, there's only one assignment of truth values that makes A arrow B come out false. That's the assignment where A is true and B is false. So you can see the sentence A arrow B as effectively saying that the assignment of values that makes it false does not hold, i.e. that it is not the case that A is true and B is false. So any sentence that says that it is not the case that A is true and B is false will come out as logically equivalent to A arrow B. And we don't have to look far because there is an obvious candidate, as I'm sure you've figured out. The sentence not A and not B will work just fine. As before, A arrow B and not A and not B are in fact tautologically equivalent. If you're in any doubt about this, then I'd encourage you to check for yourself by constructing a joint truth table. So that covers all the points I wanted to cover. Let me end with the main points for you to remember. First, the truth table for the material conditional A arrow B has it coming out false only on the assignment that makes A true and B false. It is true on all other assignments. Second, unlike the English expression if A then B, the conditional A arrow B does not assert any kind of connection between A and B other than that whenever A is true, B is true. And then third, looking at the truth table for A arrow B helps us see that it is tautologically equivalent to not A or B and also to not A and not B. So the assignment for this video is exercise 7.1 and exercise 7.2. These exercises ask you to use bool to confirm two important tautological equivalences involving the material conditional, the ones I've just described. So in the next video we'll look at the biconditional symbol. That should not take us long as most of the hard work has been done already. If you understand the conditional, then you shouldn't have much difficulty with the biconditional. So good luck with the exercises.